Hello guys, welcome back to continue the solution of worksheet 7. Okay, let's start our session today. How to solve a third question. Part 1 here. Find the critical number of f, if any. Find the open intervals on which the function is increasing or decreasing, and locate. It means find the coordinate. Okay, locate the relative extrema. The relative what? Extrema. Maximum or minimum. Before I begin to solve, I have to identify the domain of the function. Before I begin my steps, domain is what? Since it is a polynomial function, its a domain what? Or real number R. Okay? Then I'll start my steps. Here, the first step, as usual, find the derivative of the function, which is just apply the power rule on each term to x minus 4. Second term, to find the critical number. Okay? Since we are talking about polynomial function, the critical number occurs, occur on what? The values, occur when the derivative equal 0, okay? Here 2x minus 4 equal 0 implies what? X equal 2. In this case, we say critical number is what? X equal 2. But before I say critical number in the domain belongs to R in the domain, so the critical number is what? 2. But if the critical number does not include in the domain, in this case it is what? It is not a critical number. Yani the values at which the derivative equals 0, the values of x at which the derivative equals 0 are not included in the domain of the function, I can consider them what? Critical number. So it is very important. Third step, I think it's so trivial, this one. Draw a line. Okay, here from infinity to negative infinity. I'd like to know what is the interval what are the interval on which the function increasing or decreasing, okay, which is included in its domain, which included in what? Its domain. Here I write 2, the critical number on it. In this case, the critical number divide the domain of the function into how many intervals? 2 intervals. At the left of 2, which is what? Negative infinity, 2 and 2. At the right of critical number 2, it will be 2 and infinity. Fourth step, here I have to choose the test value. Test value, which is here, which I use it to identify the sign of the derivative of the function. Here, what is the number less than 2? I'll choose 1. And here I choose, you can choose any value. Then replace in what? In the derivative. In what? In the derivative. 1, it will be here, f prime. It will be what? Negative 2, less than what? 0 in this case. If the derivative on an interval, on an open interval, negative, this means the function will be decreased on this interval. Okay? Then replace by 3 in the derivative, it will be 6 minus 4, it will be, you can use your calculator to find the value of the derivative at the test value. At what? The test value. Find the derivative at the test value, which will tell me the sign of the derivative. Equal to greater than what? 0, so the function is what? Increasing. I think up to now it's so easy. So this is, I'll call this one fourth step, okay? 5th step to substitute by the test value in the derivative. 6th step here, fx is decreasing. On what? On the interval negative infinity and 2. Fx is increasing on which interval? 2 and infinity. The open interval, all of them open interval. What is the the third request? This is the first request, okay? Second request, okay? Third request. How to find the extrema? Look here. Extrema occur where? Occurs at the critical number. Here, where is the critical number? The critical number here is what? 2. Since the behavior of the function change from decrease to increase, it will be extrema, okay? But if the behavior of the function does not change before and after the critical number, so it will not, this critical number will not be extrema. Clear? Here the function is decreasing until reached to the minimum value, then become, look, decrease and then become to what? Increase until reached to the minimum value at x equal to. So in this case, the function has relative minimum, not absolute, because I'm talking about the extrema on open interval, on all of the domain, okay, or real number, okay. In this case, I will write fx has what? Relative, R here, abbreviation of relative, minimum at which value? Well, each point at 2. And what is the value of the y-coordinate of it2? F2. Because I'm asking about the coordinate location, it means where is its place. To find the y-coordinate from the original function, but I replace in the derivative if we substitute by the test value. I replace by test value in derivative. But to find the coordinate of the extrema, substitute in the function. It will be 2, and f2 use the function, it will be -4. That is the third request. Clear or not clear? I hope you understand. Repeat the video many times to understand how to solve question 3. Okay? Now, I'll solve part 3 because when we are in the live session, your friends ask me to solve number 3. I know it has a long steps, but no problem. For number 2, it is a polynomial, so easy, like the previous one. Follow the step as we did in the previous one. Sorry. Now, let's solve number 3, okay? I repeat it because some of you didn't understand well in the morning, but I repeat the solution. Here, before I begin the steps, what is the domain of this function? Domain is what? Domain all real number. R, it means all real number. Then, begin the first step. As usual, means the derivative, but here, this function is a product of 2 functions. This is one, u, and here, v. Find the u. Sorry, u equal what? X minus 1 all to power 2. It is so easy. To find the derivative of any function, I have to identify which rule I will apply. Okay? Then apply it. Okay? Decide first. Here, what is the derivative? In this case, to find the derivative of u, the function u in this case is what? A composite function. Bracket raised to power. I'll apply which rule? General power rule. Which state what? The power. Okay. Multiply the bracket. Decrease the exponent by 1. It will be 1 and the 1 can be submitted. Multiply by the derivative what inside the bracket. But since it is 1 also can be submitted. That is the derivative of the function u. V. X plus 3. So v prime, it will be the derivative of x, it will be 1. The derivative is 3, 0, okay. Then use what? The cross product. Here, the derivative of the function equal 1 multiply this one, the bracket to power 2 multiply 1, it will be x minus 1 all to power 2 plus the other product, okay, which is what? I think it's easy. Okay? Second step. Find the zero of the derivative. Miss, why every time when we find the derivative of the polynomial function, I find the zeros of it, does not exist. Since we don't have like rational function or the function which has a certain domain. But all polynomial has all real number, okay? Has all real number. Here, I will take x minus 1 all to power 2 plus 2 multiply x minus 1, x plus 3 equal what? 0. As you know, I find to solve like this, like this equation by factorization. By what? Factorization. Here, I remind you by something. What is the meaning of x minus 1 all to power 2? It means x minus 1 multiply x minus. So, I factorize by using common factor. The common factor can be number, can be variable, can be bracket. In this case, I will take x minus 1 as a common factor. X minus 1 as a what? Divide. I will cancel this one. If I divide, it will be x minus 1. Multiply, if I divide, this one cancel, it will be what? Plus 2 multiply x plus 3 equal what? 0. Then simplify, distribute this one, it will be 2x plus 3. 2x plus what? 3. Then simplify, it will be implies x minus 1, which is a common factor, multiply here. X plus 2x, it will be 3x. Sorry, 6, I'm sorry. Plus 5 equal what? 0. Find the zeros of each bracket. Here it will be what? Implies x equal what? 1 or x equal what? Negative 5 over 3. Means before I said what are the critical number, both values of x equal 1 and the 5 minus 5x negative 5x over 3 are included in the domain. Yes, so in this case critical number, before we said what are the critical number, they have to be in the domain. X equal 1 or negative 5 over 3. Okay, that is the first part. The second part, how to find the interval. Okay, I'll continue here. Sorry. Here. That is third part. I'll continue here. I'll draw the number line as you see. Negative infinity, and here what? Infinity. Write the critical number on the number line, but please from the smallest to the greatest. Negative 5/3, and here 1. Okay. Okay. Then the fourth step, or I have to choose not only the mechanism, but you have to know what is the steps which I have to follow. In this case, what is the remain to do? Here I have to find the sign of the derivative to identify where is the function increase or decrease. In this case, I'll choose here the test value. Here I have an interval, that is interval 1. Interval from here, -5 to 1. It is another interval. Third. Interval, it means the part on the number line here. -5 and -5/3, if you write it in calculator, it will be -1 and 2/3. So I'll take a number less than it in this interval. I'll choose -2. This -1 and here, -1 and 2/3. Okay, so in this case, I'll take less than it. Here, I choose 0, which make that derivative easier for me. Sorry, it's substitution in the derivative easier. But I care about the value, not the. I care about the sign, not the value. Here, I'll choose what? 2. Replace in the derivative. In what? The derivative. I replace in the simplest form. In this one. It will be negative also, and here -6. It will be positive. So the function is what? Increase. I replace here 0, -1, 0, 5. It will be negative. Sorry, -5 and negative. Okay, decrease. I replace here it positive, positive. It will be but positive. So the function is what? Increase. Clear or not clear? I replace by this one in the derivative. Here, -2, -1, it will be -3. This value negative. Okay, multiply here -6 plus it will be negative. Negative multiply negative, it will be positive. If I replace by 0, it will be -1, negative 0, it will be positive. So this one negative. Okay. Now, I write where the function is increasing and where is the function is what? Decrease. Here, f(x) is increasing on, you have to write the 2 interval. What is the first interval? And because it is interval on, sorry, increasing on 2 interval. Negative infinity. -5/3. Okay, and what else? Here increasing 1 and infinity. f(x) is decreasing on what? -5/3, 1. Please, by looking at the graph, how to locate the extrema. Extrema occur at critical number. Here, that is the first critical number, second critical number. Since the behavior of the function change here, increase, then decrease. Before it increase, okay, I'm sorry. Okay. Okay, and here what? Decrease, then become increase. Here it has what? Relative maximum, and here it has what? It has relative minimum. So, f(x), wait a minute, I'd like to have enough space to write. Okay, no. Okay, fx, okay, has a relative maximum at what? Negative 5 over 3 and f negative 5 over what? 3. You have to replace, okay? You have to what? Sorry, it is ordered pair. Okay, this one not negative. Okay? You have to substitute in the given function to find it by using what? Calculator. Okay? Fx has what? Relative minimum. Okay? At which value? What is the coordinate? At relative minimum at 1, f what? 1. But you have to replace by 1 in the original function to find the y coordinate. Clear or not clear? Here you have to find this value by using what? The calculator. I hope you understand. Here, that is the last question, then I leave you to solve the other one. Let's here solve number 5. It is a piecewise function. The domain also is what? All real number. But here this function defined by different rules on subdomain. Okay, it is defined by what? 4 minus x to power 2 on the subdomain from negative infinity to 0, closed. Here the function defined by negative 2x on the other subdomain. Okay, so what is the first step? As usual, find the derivative. How to find the derivative for each rule? It will be 0 negative 2x where x less than or equal 0. Negative 2 where x greater than 0. Okay, here I have to know the function exists or does not exist on the value of x at which we have two different what rule? At which we have different rule. Before it we have rule and after it we have rules. We have to know the function is differentiable or not differentiable at this point. But find what? Left hand derivative. Left hand derivative equal what? Replaced by 0, it will be negative 2 multiply 0, it will be 0. But the right hand derivative, it will be what? Negative 2 constant function. Since the left hand derivative not equal right hand derivative, يبقى f the derivative at x equals 0 does not exist. Or by another way, you can write f derivative 0 does not exist. It is so x equals 0 is critical number. Okay, here that is when the function differentiable or not differentiable. It is not differentiable at x equals 0. Here I have to find the zeros of the derivative. The zeros of the derivative. Here, as you see, I can the zeros of the derivative where the derivative equal 0. The derivative negative 2x equal 0 implies what? X equal what? 0. So we have a critical if the derivative equals 0 or does not exist at x equal 0. Okay. In this case, I write what? Critical number x equal 0. The critical number x equal what? 0. Have you understood? You have to discuss the function is differentiable or not differentiable at the value of x that we have different rule before it and after it or around it. Then third step, and also the critical number in the domain. In what? In the domain. Here I'll draw the line. Okay, right here what? 0, negative infinity, and here what? Infinity. We have two interval. Then replace in what? In the derivative. For all of the values of x less than 0, I replace in which rule? The first rule or in the second rule? In the first rule. Okay, but here, before we replace, I use that test value. The test value here is what? I choose here -1. Okay, then I choose here what? 1. Okay, the test value here -1. So I replace in which rule? The upper one or the lower one? Here I choose -1 in for x less than 0. X less than 0, I replace here. Okay, less than 0, I replaced in the first rule. -2 multiply -1, it will be 2 greater than 0, so the function is what? Increase. Okay, replace here greater than 0, I replace in the second one, it means negative less than 0, so the function is what? Decrease. In this case, fx is increasing on which interval? Negative infinity. All of this under the head of the question 3. 0. Fx is decreasing on which interval? 0 and infinity. But at this critical number, we have which kind of extrema? We have extrema or not extrema? Since at the critical number, the behavior of the function change from increase to decrease, I have what? Relative what? Max. Here fx has relative what? Maximum at what? The coordinate of 0 and what? f0. Replace in the function. But in which rule? The upper rule or the lower rule? fx I replace at 0, it must substitute in the rule at which x equal, or satisfied in the first interval. Has an all at this one. Okay, I write here 0, f0 replace above 0 and 4. 0 and replaced in the upper rule, it will be 4 minus 0, it will be 4. So has relative maximum at 0, 4. By the same way, solve number 6. It is so easy. If you have any question in worksheet 7, study and solve the homework. Any missing in the worksheet 7, I'll discuss in the next session. Thank you for joining or for seeing the video. Bye-bye.